oxide. Okay? You do not use, you use a prefix here. Okay, so these are the ones where you use a prefix. And just to refresh, you got the mono, you got the di, tri, you got tetra, you got penta, you got hexa, you got hepta, octa, nano, deca, dodecal, all that business, right? Okay, but no prefix on the first one, guys, if it's 1. Always a prefix on the second one, though, even if it is 1. Like, for example, this little guy here, which has made tons of money, NO. This is called nitrogen what? Nitrogen, nitrogen monoxide. All right, does anybody know why this is the claim to fame here? Why this has made tons of money? 2 atoms. Well, this dilates blood vessels. Pharmaceutical companies loved it because they thought it would be a wonderful way to lower blood pressure. Instead, it gave men erections. Viagra. All right? I'm serious. Now, Viagra doesn't look like that. Certainly, I'm talking about the metabolic byproducts. Have an NO in the reaction cascade. Okay, now let's talk about this second ending here. Look at here. This is nitrogen monoxide, right? Well, why didn't you call it monoxide? I mean, you told me the prefix was mono. Why is it not monoxide? Well, here's the rule. You drop that vowel, okay? Anytime there are 2 vowels together, except if one of them is in an I. Take a look. Monoxide, I dropped the vowel, right? Dioxide, did I drop the vowel here? Oh, why? Because one of them's an I. Tetraoxide, tetraoxide, did I drop a vowel? Yeah, was one of them an I? No, so I got rid of it. Does that make sense? So on the second one, whenever you have the prefix with a name, if there are 2 vowels together, you do not, you drop it unless one of them's an I. All right? Even if you had something like tetraiodide, let's try CI4. This right here would be called carbon tetraiodide. Well, see, we got 2 vowels there, A and an I. Well, we keep it. We don't drop that. Why? Because there's an I there. You see, the I doesn't have to be part of the prefix. Okay, so what have we done? We did metals and nonmetals. We did metals and polyatomics. We did 2 nonmetals. The fourth one is what is called multivalency. All right. You see, in the periodic table, to my knowledge, this is called multivalency. Page 113 is the way you're going to go on this one, right? If you look at the periodic table, which we don't have one, let me see if I can get one up here in front of us so we can see here. So how am I doing so far? Good? Wonderful. And you're telling me Mary didn't talk about this, right? So when I go back and look at the video, she was in here talking about Taco Bell, right? And the little cinnamon twist. Was that what she was talking about? Now come on now, guys. All right. So, did you guys know a real neat story is that me and her graduated from the same PhD professor at Auburn, and we did not know each other until we came down here. She graduated like 6 years before me. For years I've read her dissertation, her work, knew of her as a chemist, but had never met her. Now we're 4 doors apart, which is a pretty neat world, right? She graduated in '96, and I graduated in '04. Okay, we're talking here about valence. Those are oxidation states. To my knowledge, there are no known examples where lithium, sodium, potassium, rubidium, cesium, and francium have any other oxidation state but what? +1. There are no known examples except where beryllium, magnesium, calcium, strontium, barium, and radium have oxidation states of what? Are they multivalent? No. There's one example. Fluorine's another one. There are no examples till I know of where fluorine is not a what? -1. Any other things, all bets are off. Okay? Now your simple freshman chemistry book will tell you that aluminum only exists as +3. No, I've seen examples. I think there's 5 examples that I've seen. 1998 where aluminum 1 compounds were made at Berkeley. You see Berkeley. All right, so there are other things that they can make it happen. Now, aluminum 3 is by far the most common, right? You're on an MCAT, but aluminum 3. Okay. Now, what about these transition metal get-ups? And what are called post-transition metals? That means the metals that exist after the transition metals. How's that going to work for you? Well, you certainly do not have to memorize all of them, right? We're in the freshman class, which means we're going to do introductory stuff. Is iron important? Yes. Exists as a +2 and a +3 are 2 common ones. Is copper important? Yeah, it exists as a +1 and a +2. Is zinc important? Yeah, it exists as a what? +2 only. All right. What about silver? +1 only. All right. What about molybdenum? Nah, it's not in your book, right? Who cares? Right? And who does care, right? Molybdenum has a great, wonderful chemistry. What the hell are you going to use it for in everyday life? You with me? All right. Now let's see what else here. Here's one. Mercury. You heard of mercury, right? It goes a +1 and a +2. What about lead? 2 and a 4. And tin is a +2 and a +4. And these are things that are called multivalent. On page 113 in your book, I think, somebody count, there are 7 examples that you have to know. All right. There's arsenic, there's titanium, there's lead, there's copper, there's iron. There's what?
You gave us this yesterday, silver and tin.
Yeah, silver and that's on there. What other? Tin is on there, that's 6, and I think there's one more. Mercury. Did I say mercury? Copper, mercury? I think I said 7. Iron, that's the one I forgot. That's the 7th one, iron. Okay, so how would you name such a beast? Well, here it is. You can have a compound that's named FeCl2 and another one that's FeCl3. This one right here would be called iron 2 chloride. Now, how did I get that? Let's look at it. Iron has a +2 charge and chlorine has a -1 charge. We play the switcheroo, never write the 1. That's where the 2 comes from. So that's an iron 2 chloride. Now this one right here is called a what? An iron 3 chloride. All right. Now let's look at old-timey names. Right. This is what's called the stock system. It's named after a guy named Stock. All right, not after the stock room, but after a guy named Stock. Now this is called ferrous chloride, and this is called ferric chloride. All right, let's take a look. How are you going to know this? If you look, every single ending in that chapter either ends in an OUS or an IC, so how are you going to get it figured out? Each one has a low number and a high number. This has 3 letters, OUS. The word low has 3 letters.